ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಇದು ಡಿಟರ್ಮಿನೆಂಟ್ಸ್ ಪಾರ್ಟ್ 13. ಹಿಂದಿನ ವಿಡಿಯೋದಲ್ಲಿ ನಾವು ಸೊಲ್ಯೂಷನ್ ಆಫ್ ಸೈಮಲ್ಟೇನಿಯಸ್ ಲೀನಿಯರ್ ಈಕ್ವೇಷನ್ ಬೈ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಮೆಥಡ್ ಈ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ಇವತ್ತಿನ ವಿಡಿಯೋದಲ್ಲಿ ನಾವು ಸೊಲ್ಯೂಷನ್ ಆಫ್ ಸೈಮಲ್ಟೇನಿಯಸ್ ಲೀನಿಯರ್ ಈಕ್ವೇಷನ್ಸ್ ಅನ್ನು ತೆಗೆದುಕೊಂಡು ಮತ್ತೆ ಇನ್ನೂ ಕೆಲವು ಪ್ರಾಬ್ಲಮ್ಸ್ಗಳನ್ನು ತೆಗೆದುಕೊಂಡು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಹಿಂದಿನ ವಿಡಿಯೋದಲ್ಲಿ ನಾವು ನೋಡಿದ್ವಿ ಸೈಮಲ್ಟೇನಿಯಸ್ ಲೀನಿಯರ್ ಈಕ್ವೇಷನ್ಸ್ ಇದ್ದಾಗ ಕೋಎಫಿಷಿಯೆಂಟ್ಸ್ ಆಫ್ ಎಕ್ಸ್ ವೈ ಝೆಡ್ ಅನ್ನು ತೆಗೆದುಕೊಂಡು ಅದನ್ನು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಫಾರ್ಮಲ್ಲಿ ಬರೆದು ನಾವು ಅಡ್ಜಾಯಿಂಟ್ ಅನ್ನು ಕಂಡುಹಿಡಿದು ಇನ್ವರ್ಸ್ ಆಫ್ ಎ ಕೋಎಫಿಷಿಯೆಂಟ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನು ತೆಗೆದುಕೊಂಡು ಎಕ್ಸ್ ವೈ ಝೆಡ್ ನ ವ್ಯಾಲ್ಯೂನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ವಿ. ಇಲ್ಲಿ ಇವತ್ತು ಈ ಅಡ್ಜಾಯಿಂಟ್ ಮತ್ತು ಇನ್ವರ್ಸ್ ಅನ್ನು ಕಂಡುಹಿಡಿಯುವಂಥ ಸರಳವಾದ ಒಂದು ಶಾರ್ಟ್ ಟ್ರಿಕ್ ಅನ್ನು ತೆಗೆದುಕೊಂಡು, ಅಂದರೆ ವಿತೌಟ್ ಫೈಂಡಿಂಗ್ ದಿ ಕೋಫ್ಯಾಕ್ಟರ್ಸ್ ಆಫ್ ದ ಎಲಿಮೆಂಟ್ಸ್, ಅದು ಯಾವುದೂ ಇಲ್ಲದೇನೆ ನಾವು ಸರಳವಾದ ವಿಧಾನವನ್ನು ತೆಗೆದುಕೊಂಡು ಇವತ್ತು ಈ ಪ್ರಾಬ್ಲಮನ್ನು ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಈಗ ತೆಗೆದುಕೊಂಡಿರೋ ಪ್ರಾಬ್ಲಮು ಒಂದು ವರ್ಡ್ ಪ್ರಾಬ್ಲಮ್. ಇದನ್ನು ನಾವು ಈಕ್ವೇಷನ್ಸ್ ಆಗಿ ಫಾರ್ಮ್ ಮಾಡಬೇಕು. ಈ ಪ್ರಾಬ್ಲಮಿಗೆ ಏನಿದೆ ಅಂದರೆ, ದ ಕಾಸ್ಟ್ ಆಫ್ 4 kg ಆನಿಯನ್, 3 kg wheat ಆ್ಯಂಡ್ 2 kg ರೈಸ್ ಈಸ್ ₹16. ಅದು ಮತ್ತೆ ಸೇಮ್ ಆನಿಯನ್, ವೀಟ್, ರೈಸ್ ರಿಪೀಟ್ ಆಗುತ್ತೆ. ದ ಕಾಸ್ಟ್ ಆಫ್ 2 kg ಆನಿಯನ್, 4 kg wheat, 6 kg ರೈಸ್ ಈಸ್ ₹90. ಇಲ್ಲಿ ಡಿಫರೆಂಟ್ kg ಇದೆ ಪ್ರತಿಯೊಂದು ಸೆಂಟೆನ್ಸಲ್ಲೂ ಕೂಡ. ದ ಕಾಸ್ಟ್ ಆಫ್ 6 kg ಆನಿಯನ್, 2 kg wheat and 3 kg ರೈಸ್ ಈಸ್ ₹70. ನೋಡಬೇಕಿಲ್ಲಿ ಇಲ್ಲಿ ಡಿಫರೆಂಟ್ ಫ್ಯಾಕ್ಟರ್ಸ್ಗಳಿದೆ. ಅಂದರೆ 4 kg ಇದೆ, 3 kg ಇದೆ, 2 kg ಇದೆ. ದ ಐಟಮ್ ಆರ್ ರಿಪೀಟೆಡ್, ಆನಿಯನ್, ವೀಟ್ ಆ್ಯಂಡ್ ರೈಸ್. ಸೊ ಹಾಗಾದರೆ ನಮಗೆ 1 kg ಆನಿಯನ್ನ ಬೆಲೆ ಅಥವಾ ವೀಟ್ ಅಥವಾ ರೈಸ್ ಎಷ್ಟು ಅನ್ನೋದನ್ನು ನಾವು ಕಂಡುಹಿಡಿಯಬೇಕು. ಸೊ ಈಗ ನಾವು 1 kgಗೆ ಆನಿಯನ್ ಬೆಲೆ ಎಕ್ಸ್ ಅಂತ ತೆಗೆದುಕೊಳ್ಳೋಣ. ಅದು ನಮಗೆ ಗೊತ್ತಿಲ್ಲ. ದಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಔಟ್. ನಾವು ಲೆಟ್ಸ್ ಟೇಕ್ ದಟ್ ಲೆಟ್ ದಿ ಕಾಸ್ಟ್ ಆಫ್ ಆನಿಯನ್ per kg be x. Similarly, let's consider the cost of wheat per kg be ₹y. So let's take this is ₹x, and the cost of rice per kg be ₹z. ಸೊ ಈಗ ನಾವು ಎಕ್ಸ್, ವೈ, ಜೆಡ್ ಅಂತ ತೆಗೆದುಕೊಂಡಿವಿ. ಇದನ್ನು ನಾವು ಈಗ ಈ ಈಕ್ವೇಷನ್ಸನ್ನು ನಾವು, ಅಂದರೆ ಈ ವರ್ಡ್ ಪ್ರಾಬ್ಲಮನ್ನು ನಾವು ಈಕ್ವೇಷನ್ಸ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡೋಣ. ಅಂದರೆ ಈಗ 1 kgಗೆ ಎಕ್ಸ್ ಅಂತ ಅಂದರೆ, ಈಗ 4 kg ಆನಿಯನ್, 3 kg ವೀಟ್, 2 kg ರೈಸ್ ಅಂತ ಅಂದರೆ ಏನಾಗುತ್ತೆ? ಸೊ ದಟ್ ಈಸ್ ಗಿವನ್ ಆ್ಯಸ್ 4x 4 into 1 kg ಆನಿಯನ್ ಪ್ಲಸ್ 3y, ಅಂದರೆ y ಈಸ್ ದಿ ಪರ್ kg ಪ್ರೈಸ್ ಆಫ್ ವೀಟ್, ಆ್ಯಂಡ್ ಪ್ಲಸ್ 2 into z ಈಸ್ ದಿ ಪರ್ kg ಪ್ರೈಸ್ ಆಫ್ ರೈಸ್. ಟೋಟಲ್ ಮಾಡಿದ್ರೆ ಏನಂತ ಕೊಟ್ಟಿದ್ದಾರೆ? 60 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ನಾವು ಸಿಮಿಲರ್ಲಿ ಲೆಟ್ಸ್ ರೈಟ್ ದ ಸೆಕೆಂಡ್ ಸೆಂಟೆನ್ಸ್, 2 kg ಆನಿಯನ್, ಸೊ 2x ಪ್ಲಸ್ 4 kg wheat, 4y ಪ್ಲಸ್ 6 kg ರೈಟ್, 6z is equal to 90. And next is 6 kg onion, 6x plus 2y plus 3z is equal to 17. ಈಗ ನಾವು simultaneous linear equations ನಮಗೆ ಸಿಕ್ಕಿದೆ. ಈಗ ಇದನ್ನು ನಾವು ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಹೋಗೋಣ x y z ಅನ್ನು. ಈಗ we are writing, let us take, let A as the matrix of the coefficients ಏನಿದೆ 4 3 2 2 4 6 6 2 3. Now let's write x as the coefficient of the matrix of unknown, that is x y z, that we have to find out, and b is the constant terms 60 90 70. We know that the above equations can be written in the form of can be written in the form Ax is equal to b. We know that the solution is x is equal to A inverse into b, where A inverse is 1 by determinant of A into adjoint of A. Okay, now let's find out determinant of A. So what is the determinant of A? Determinant of A equals, taking the determinant of the matrix, 4 into expanding along the first row, 4 into 4 in the determinant of 4 6 2 3 is 4 3 are 12 minus 12 minus 3 into the determinant of 2 6 6 3, that is 12 minus 36, that is 6 minus 36, because 2 into 3 6 minus 36 plus 2 into the determinant of 2 4 6 2, and that is 4 minus 24 equals 4 into 0 minus 3 into 6 minus 36 is minus 30, and plus 2 into 4 minus 24 is minus 20, is equal to 0 plus 90 plus, that is 2 into minus 20 is minus 40, 90 minus 40 is equal to 50. So clearly it is not equal to 0. We know that inverse exists when the determinant of A is not equal to 0, that is when the matrix is non-singular. So we conclude, hence A inverse exists. If determinant of A equals 0, then the A inverse does not exist. Now the remaining thing is we have to find the adjoint of A. So to find the adjoint of A, now I am going to write the, so we are taking here one of the important shortcut. So what is A? Let's write once again. A is a matrix 4 3 2 and 2 4 6 6 2 3. I have written once again. So what I am doing here, to find the adjoint of the matrix, first before that we need to take cofactor matrix. The transpose of the cofactor matrix is the adjoint. So instead of taking the cofactors of all the elements, so let's take one shortcut here. So what I am doing here, see, I will write the matrix here 4, 3, 2 and 2, 4, 6 and 6, 2, 3. So now here we have, this is column 1, column 2. So I will repeat these column 1 and column 2 once again here. So that is 4, 2, 6, 3, 4, 2. Observe that the first column 1 and column 2 is written once again. Column 1 and column 2. Here this is column 1 and this is column 2 written once again. So we have now, next we have this one as R1. This is row 1 now, this is row 2 with repeated columns 4, 3, 2, 4. Now I will repeat these R1 and R2 once again. R1 and R2 once again below these rows. So what is R1 and R2? R1 is this one 4, 3, 2, 4, 3. So that is 4, 3, 2, 4, 3. And next is second row R2 2, 4, 6, 2, 4. So once again I am writing that 2, 4, 6, 2, 4. Okay, we have this pattern. Now let's take the eliminate the first row, this one, first row, this one, first row and the first column. So we have to eliminate the first row and the first column. After eliminating the first row and the first column, now let us multiply the elements. Remaining elements are this. These are the remaining elements. So these are the remaining elements. This one. Okay. So these are the remaining elements. So now I am taking the determinant of the elements one by one. So here this is 4, 6 and 2, 3. Determinant of this, taking the determinant of this and writing the adjoint cofactor matrix. So let us write the cofactor matrix here. Cofactor matrix. Cofactor matrix. So that is equal to matrix. Let's write it directly. 4, 6, 2, 3. Determinant of this 4 into 3, 12 minus 12 is 0. Next, the determinant of 6, 2, 3, 6, multiplying the elements crosswise. 6 into 6, 36 minus 3 into 2, 6. So 36 minus 6 will be 30. This is 30. Then after that, the determinant of this 2, 4, 6, 2, next one. So taking this, multiplying the elements crosswise, 2 into 2, 4 minus 6 into 4, 24. So 4 minus 24 is minus 20. Now, next we have to take the next second and the third row. 2 multiplying the elements crosswise. 2 into 2, 4 minus 3 into 3, 9. So, 4 minus 9 will be minus 5. Next, taking these elements, 3 into 4, multiplying the elements crosswise, 3 into 4 minus 6 into 2, 12. So, 3 into 4, 12 minus 12 is 0. 12 minus 12 is 0. Then, next determinant, that is the multiplying the elements crosswise, 6 into 3, 12 minus 2 into 4, 8. So, 12 minus 6 into 3, 18. 6 into 3, 18 minus 8. So, 18 minus 8 is 10. Next, taking the next rows, here this one, 3 into 6, multiplying the elements classwise, 3 into 6 minus 4 into 2. 3 into 6, 18 minus 8. So, 18 minus 8 is 10. Then 2 into 2, 4 minus 6 into 4, 24. So, 4 minus 24. 4 minus 24 is minus 20. Then next 4 into 4 minus 3 into 2, 6. So, 16 minus 6. 16 minus 6 is 10. Okay. So, this is the cofactor matrix. Now, the problem is simple. Illi the benefit is we are not considering the plus, minus, plus sign for the cofactors of the elements. So, now direct agi without taking the sign of the cofactor, we are finding directly using this pattern. So, therefore, now the adjoint is adjoint of the matrix. Adjoint of the matrix is taking the transpose, that is 0, 30, minus 20 and minus 5, 0, 10, 10, minus 20, 10. So, ಈಗ ನಾವು adjoint ಅನ್ನು find out ಮಾಡಿದ್ರೆ almost all problem is over. ಈ adjoint of a matrix ಅನ್ನು ನೇರವಾಗಿ ಕೂಡ ನಾವು ಬರಿಬಹುದು. Here what I have written here, I have written the elements, cofactors of the elements row wise. If you take here row wise, if you write column wise, the elements column wise, you will get the adjoint of the matrix directly. So, without writing the cofactors of the cofactor matrix, instead of writing the elements horizontally, row wise, if you write column wise, you will get the adjoint of the matrix directly. A inverse is equal to 1 by determinant of A, 1 by determinant of A, 1 by determinant of A. Determinant of A, we are getting 50 into adjoint of A. Adjoint of A is 0 minus 5, 10, 30, 0, minus 20 and minus 20, 10, 10. Now, we have x is equal to A inverse B is the solution of this equation. So, now x equals A inverse B, A inverse is 1 by 50 into 1 by 50 into 0 minus 5, 10, 30, 0, minus 20 minus 20, 10, 10 into the adjoint B. Adjoint we have find out into B. B is 60, 90, 70. This is the column matrix having the constant of the equation. Now multiplying the two matrices 1 by 50 into taking the matrices row wise column wise, 0 into 60 is 0, minus 5 into 90 minus 450 plus 10 into 70 700 and 30 into 60 1200, 30 into 6 1800 plus 0 minus 20 70 is minus 1400. Then minus 20 into 60 is minus 1200 plus 900 and plus 700. Now this is equal to 1 by 50 into minus 450 plus 700 is 250, 1800 minus 1400 400, minus 1200 plus 900 700, 16 1600 minus 1200, that is 400. So when you multiply all the elements by 1 by 50, that is dividing by 50, we are getting 250 by 50 is 5 and this is 8 and this is 8. Now so we have xyz, this is x value is xyz. So taking the corresponding elements, this implies x is equal to 5, y is equal to 8, z is equal to 8. So this is the values of xyz. Here we have used the different method to find the adjoint of a matrix. You can also find, if it is easier for you, you can find the cofactors of each element separately, then find the cofactor matrix and write the adjoint. So if it is easy for you, if this pattern is easy to write and remember, it is better to remember the pattern, and to get, if you get good practice, definitely you will get the adjoint of a matrix by this pattern also. It is left to you to choose the method. Consider this problem. Use the product matrix 1 minus 1 2 0 2 3 0 2 minus 3 3 minus 2 4 and minus 2 matrix minus 2 0 1 9 2 minus 3 6 1 minus 2 to solve the system of equation x minus y plus 2z equals 1, 2y minus 3z equals 1, 3x minus 2y plus 4z is equal to 2. ಸೊ ಈಗ ಇಲ್ಲಿ ಈ ಪ್ರಾಡಕ್ಟ್ ಅನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಸಿಸ್ಟಮ್ ಆಫ್ ಈಕ್ವೇಷನ್ಸ್ ಅನ್ನು ಸಾಲ್ವ್ ಮಾಡಿ ಅಂತ. ಈಗ ನಾವು ಫಸ್ಟ್ ಈ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಟೂ ಮ್ಯಾಟ್ರಿಸಸ್ ಅನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡೋಣ. ಇಲ್ಲಿ ನಮಗೆ ಒಂದು ಗೊತ್ತಾಗ್ತಾ ಇದೆ, ಈ ಫಸ್ಟ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಏನಿದೆ, that first matrix is the coefficients matrix of the coefficients of the equations. Nodi, what is the coefficients of the equations? 1 minus 1 2 here in the first row, in the first matrix. The coefficient of second equation is x is not given here, that should be taken as 0 0 2 minus 3. In the third equation, we have 3 minus 2, 4, that is given in the first matrix. So we have to check what is the second matrix. For this we have to use the product. Multiply ಮಾಡಬೇಕು. Now consider the product. So the first matrix, it is given as 1 minus 1 2 0 2 minus 3 3 minus 2 4. Second matrix, minus 2 0 1 9 2 minus 3 6 1 minus 2. So multiplying these two matrices, taking rows for the first matrix and columns for the second matrix. Both are 3 by 3 matrices. They are comfortable for multiplication. So now first column and the first row and the first column, sum of the products of the element, the first row and the first column, 1 into minus 2 is minus 2 and minus 1 into minus 9 is minus 9 plus 2 into 6 is 12. Now the first row and the second column, 1 into 0 0 minus 1 into 2 is minus 2 plus 2 into 2 is 2. Then the first row and the third column, 1 into 1 is 1, minus 1 into minus 3 is plus 3 and plus 2 into minus 2 is minus 4. Now the second row and the first column, 0 into minus 2 is 0 plus 2 into 9 is 18 minus 3 into 6 is minus 18. And second row and the second column, 0 into 0 0 plus 2 into 2 4 minus 3 into 1 is minus 3. Second row and the third column, 0 into 1 is 0 minus 2 into minus 3 is minus 6 minus 3 into minus 2 is plus 6. And the third row and the first column, 3 into minus 2 is minus 6 plus minus 2 into 9 is minus 18 and plus 24. Then third row and the second column, 3 into 0 0 minus 2 into is minus 4 plus 4 into 1 is 4. Third row and the third column, 3 into 1 is 3 minus 2 into minus 3 plus 6 and 4 into minus 2 is minus 8. So simplify this, we are getting minus 2 minus 9 minus 11 plus 12 is 1, minus 2 plus 2 is 0, 4 minus 4 is 0, 18 minus 8 0, 4 minus 3 is 1, this is 0, minus 6 minus 18 minus 24 plus 24 is 0, this is also 0, 3 plus 6 is 9 minus 8 is 1. So what we have? So we are getting the identity matrix of order 3 by 3. So we have, when the two matrix multiplication, the product of the two matrices is I, then immediately we can confirm that we have, so when AB is equal to I, then we conclude the inverse of the matrix is equal to B. So similarly here, the inverse of the matrix 1 minus 1 2 0 2 minus 3 3 minus 2 4, the inverse of the matrix is equal to, it is given, so minus 2 0 1 9 2 minus 3 6 1 minus 2. ಏನಾಗಿದೆ ಇಲ್ಲಿ ಅಂದರೆ, they have given the inverse of the matrix, that is the coefficient of the matrix of the coefficients were given indirectly. So when you take the product, we are getting the identity matrix. So therefore, the first matrix is the matrix of the coefficients. So these they have given indirectly. So here no need to find the cofactors of all the elements. So therefore, the system of equations can be written in the form of the given system of equation. We can write the given system of equation can be written in matrix form as follows. That is, we have to write the Ax is equal to b, that is 1 minus 1 2 0 2 minus 3 3 minus 2 4 and x is xyz and matrix of the constant is 1 1 2. This is given in the given equation, that is this equation, x minus y plus 2z equals 1, 2y minus 3z equals 1, 3x minus 2y plus 4z is equal to 2. Here in the second equation, the coefficient of x is 0. So we have taken here. So therefore, this is equal to the matrix equation is xyz. This can be written as xyz is equal to the inverse of the matrix. So this is Ax is equal to b, this is Ax is equal to b, therefore x is equal to A inverse into b. So the A inverse is 1 minus 1 2 0 2 minus 3 3 minus 2 4 minus 1, because the A inverse, this is A inverse into b is 1 1 2. So therefore, we have this is 1 minus 1 2 in my A inverse that we have find out already. xyz is equal to the inverse of the matrix 2 0 1 minus 2. Actually this is given, we have find out minus 2 0 1 9 2 minus 3 and 6 1 minus 2 into 1 1 2. So now this is, you can multiply first row and the first column, minus 2 into 0, minus 2 into 1 is minus 2 plus 0 plus 2 and 9 plus 2 minus 6 and 6 plus 1 minus 4. So we have the column matrix as 0 5 3. So equating the corresponding elements, we are getting x is equal to x equals 0, y equals 5, z equals 3. So these are the solution of the given equation. Now take this different problem. Solve for x, y and z. 2 by x plus 3 by y plus 10 by z equals 4. 4 by x minus 6 by y plus 5 by z equals 1 and 6 by x plus 9 by y minus 20 by z equals 2. ಇಲ್ಲಿ the question were given in the indirect form, ಅಂದರೆ ನೇರವಾಗಿ ನಮಗೆ simultaneous linear equations ಹೇಗಿರುತ್ತೆ ax plus by plus cz equals d, ಈ ರೀತಿಯಾಗಿ ಇರಬೇಕಾಗಿತ್ತು, ಹಾಗಿಲ್ಲ. ಎಕ್ಸ್ ವೈ ಜೆಡ್ ಒಂದು ರೀತಿಯಾಗಿ ರೆಸಿಪ್ರೋಕಲ್ಸ್ ರೀತಿಯಲ್ಲಿ ಇದೆ, 1/x 1/y 1/z ರೀತಿಯಲ್ಲಿ ಇದೆ. ಹಾಗಾಗಿ ನಾವು ಇದನ್ನು ನಾವು ಹೇಗೆ ತಗೊಳ್ಬೋದು ಅಂತಂದರೆ, ಈಗ ನಾವು ಲೆಟ್ಸ್ ಟೇಕ್ ದಿ ಸೊಲ್ಯೂಷನ್. So consider this 1/x, let 1/x is taken as a and 1/y is taken as b and 1/z as c. So completely this equation will become, the equation will be 2x plus, it is not 2x, it is 2a. It is 2a plus 3b plus 10c is equal to 4. Next 4a, here is 4/x minus 6/y, so it is minus 6b plus 5c is equal to 1. Then the third equation is 6/x plus 9/y minus 20/z, so this can be written as 6a plus 9b minus 20c is equal to 2. Now to solve this system of equation, consider the matrix. Let A equals the matrix of the coefficients 2, 3, 10, 4, minus 6, 5, 6, 9, minus 20, and x is x, y, z, and B is a matrix of constant 4, 1, 2. Now the system of equations can be written as Ax equals B, so it can be system of equations can be written as Ax is equal to B. The solution of this equation is given by x is equal to A inverse into B, where A inverse is equal to 1 by determinant of A into adjoint of A. So now to find determinant of A for the matrix A, the determinant of A is 2 into, expanding along the first row, 2 into minus 6 into 20, that is 120 minus 45, then minus 3 into expanding the determinant, so 3 into the determinant of 4, 5, 6, 20, so 4 into minus 20 minus 80, 6 into 5 minus 40. sorry, that is 30. 6 into 5 minus 30 plus next 10 into 4 into 9 36 minus of 6 into minus 6 minus 36. So simplifying, 120 minus 45 is 75 minus 3 into minus 80 minus 30 minus 110 plus 10 into 36 minus of minus 36 plus 36, that will be 72. So now this is 2 into 75 is equal to 150 minus 3 into minus 110, it is 330 plus 10 into 72, 720 is equal to 150 plus 330 plus 720 is 1200, is not equal to 0. So therefore the given system of equation has unique solution. The system of equation are consistent with unique solution, that is A inverse exists. Now to find A inverse, we need to find adjoint of the matrix. For this, now let's take, to find A inverse, let us take the matrix again and let's take the short trick here. So here I am writing the matrix 2, 3, 10, 4, minus 6, 5 and 2, 3, 10. So note that here this is the matrix. Check it again, 2, 3, 10, 4, minus 6, 5, 6. Okay, this is actually, this will be, this is 6, 9, minus 20. So now this is column 1, column 2. Repeat column 1 and column 2. 2, 4, 6, 3, minus 6, 9. Now repeat R1 and R2. So that is repeating the R1 and R2 again here. 2, 3, 10, 2, 3, 4, minus 6, 5, 4, minus 6. So now eliminating the rows, first row and the first column here. Now we have to take the adjoint of the matrix. So the adjoint is here, that is adjoint of the matrix. I am writing it directly. Adjoint of A is equal to, that is so here this is crosswise multiplication, minus 6 into minus 20, that is 120 minus 9 into 5, 45. So I am calculating row wise in this pattern. but writing column wise in the taking adjoint of A. Now here this is 5 into 6, 30. So writing column wise here minus. So minus 20 into 4 is minus of minus will be plus 80. Then 4 into 9, 36 and minus 6 into minus 6 minus 36, it will become plus 36. Next. So I have taken row wise here and writing column wise here in adjoint of A. Then 9 into 10 here 90 minus 3 into minus 20 plus minus of minus, that will be here, this will become plus 60. Now minus 20 into 2 minus 40 and 10 into 6, that is minus 60. 6 into 3 18 minus 2 into 9 18. Now the last column. So here 3 into 5 15 and 10 into minus 6 minus of minus, which will become plus 60. Then 10 into 4 40 and 5 into 2 minus 10. 2 into minus 6 is minus 12 minus 4 into 3 is 12. So that completes adjoint. See here in this pattern we have calculated the row wise and writing column wise in taking the adjoint. So now this is equal to, simplifying this, 120 minus 45 is 75. It is 1110. This is 72. And it is 90 plus 60, 150. And this is minus 100. This is 0. 15 plus 60 is 75. 40 minus 10 is 30. Minus 12 minus 12 minus 24. So we are calculating adjoint of A directly. ಇಲ್ಲಿ examination ಅಲ್ಲಿ they are not going through how to find the cofactors of the elements. So therefore we can write the adjoint of the matrix directly. So therefore we can write the adjoint directly and by taking this pattern, and each element must be correct. Okay. You can compare this result with the usual method by finding the cofactors of each element. So now the benefit of this method is you can avoid the mistakes in making the negative or positive sign in finding the cofactor. So here we can find out directly without taking any sign of the cofactors, plus minus plus like that. So adjoint of A we have find out. Now we can get the inverse. The inverse is given by x is equal to A inverse B. So therefore A inverse is, we can write A inverse is equal to 1 by determinant of A is 1 by 1200 into writing this 75, 110, 72, 150 minus 100, 0, 75, 30 minus 24. So now you can taking x is equal to A inverse B. So taking now, writing here x is equal to A inverse into B. So is equal to A inverse is 1 by 1200 into matrix 75, 150, 75, 110 minus 100, 30, 72, 0 minus 24 into matrix B. B is a matrix of constant 4, 1, 2. So multiplying these two matrices, 1 by 1200 into, so now 75 into 4 is 300 plus 150 plus 75 into 2 150, 110 into 4 440 minus 100 plus 60, 72 into 4 is 288 plus 0 minus 24 is minus 48. So we can write 1 by 1200, calculating the addition of these results. 300 plus 150, 150, 300, 300 plus 300 is 600. 440 minus 100 plus 60, finally we arrive the result, that is 400. 288 minus 48 is 240. So now this is equal to, now 1 by 1200 into 600, it is 1 by 2. 400 by 1200 is 1 by 3. 240 by 1200 is 1 by 5. So we have X is what? It is A, B, C. So we have A is 1 by 2, B is 1 by 3, C is 1 by 5. But what is X? 1 by X is taken as A, 1 by Y is taken as B, 1 by Z is taken as C. Therefore, A is 1 by 2. Now, here this implies A is 1 by 2 ಆಯಿತು ಅಂದರೆ what is X here? X is 2, because see here this is the reciprocal, so 1 by A is 2. So 1 by A is 2, that is X. 1 by A is 2, 1 by B is 3, 1 by C is equal to 5. Or we can take X is equal to 2, Y is equal to 3 and Z is equal to 5. So A is the reciprocal of X. So 1 by X is A. So A is X is 2, Y is 3, Z is 5. So this is the value of X, Y, Z for this equation. Now consider this problem. If A is equal to matrix 2 minus 3 5, 3 2 minus 4 1 1 minus 2. Find A inverse. Using A inverse, solve the system of equations. 2x minus 3y plus 5z equals 11. 3x plus 2y minus 4z equals minus 5. X plus y minus 2z equals minus 3. So here they have given the matrix of the coefficients directly here. So just check with matrix A with the coefficients of x, y, z in the equation. They are nothing but the coefficients of equation x, y, z in the equation. That is 2 minus 3 5, 3 2 minus 4 1 1 minus 2. So now we have to find out A inverse. So in this case also we can take, let A is, it is given already, that is 2 minus 3 5 3, 2 minus 4, 1, 1 minus 2. And x is taken as x, y, z, and B is taken as matrix of constants is 11, minus 5, minus 3. Now, the system of equation can be written as system of equations can be written as Ax is equal to B. So now let's find out determinant of A, because whether we get a unique solution or not. So determinant of A must not be equal to 0 to get a unique solution. So therefore, so taking the determinant of A, 2 into minus 4 plus 4, okay, plus 3, because minus of minus 3 is plus 3 into 3 into minus 2 minus 6 plus 4, and plus 5 into 3 minus 2. Go through the matrix A and find out the determinant. So 2 into 0 plus 3 into minus 6 plus 4 is minus 2, plus 5 into 3 into 2 is 1. That is 3 into minus 2 minus 6 plus 5. So it is minus 1 is not equal to 0. So therefore, the given system of equation, you have to conclude this statement, the given system of equation, by showing determinant of A not equal to 0. You have to conclude this statement, the given system of equation are consistent with unique solution. So now let's find out A inverse. So A inverse is as 1 by determinant of A into adjoint of A. Now to find A inverse, we have to calculate adjoint of A. So now let's calculate adjoint of A using the short trick. So what is the matrix here? See one thing, this is the matrix here, this is the matrix. A is given as that is 2 minus 3 5 3 2 minus 4 1 1 minus 2. Alternatively, I will also take like this. So actually the cofactor matrix is, you can take like this, you can take minor of 2, the minor of 2 is this, you have to write minor of 2, and minor of 5, let us take minor of 5, so minor of 5, and next take minor of 1, and this one minor of minus 2. You know how to calculate minor of an element. So now write the minor of 2 here. Minor of 2 is the determinant of that 2 minus 4 1 minus 2. Here this is 2 minus 4, the elements 2 minus 4 1 minus 2, taking the determinant, but I have not taken the determinant here. So writing the elements, the minor of 5 is 3, determinant of 3 2 1 1, so I am not writing the determinant symbol here. The minor of 1 is here, minor of 1 is, that is minus 3, 5 and 2 minus 4. 2 minus 4. The minor of minus 2 is here, 2 minus 3, 3, 2. So you can calculate the adjoint by taking this pattern like this here, like this. So this is same as the previous method, just I have changed because you can take here, this is the row, the matrix is here, this you can take here because I have not taken the top row and the first column here. So what we have to add here, this is the matrix, observe that this is the matrix, this is 2, this is 2, 2 minus 3, 5, 2 minus 3, 5, because this is the matrix, this is 2 minus 3, 5 and this is 3, 2, 3, 1. See, 2 minus 3, 5, this is 2, 3, 1. So we are getting now, observe that. So this is 2 minus 3, 5, 3, 2 minus 4, 1, 1 minus 2. So we have this matrix actually. We have this matrix. So now writing again, this is 2 minus 3. So we have taken, this is column 1, this is column 2, repeated column 1 and column 2. So now repeating row here, this is row wise, this is row 1 and this is row 2 here. So 2 minus 3, 5, 2 minus 3. So this is, you have to take 2 minus 3, 5, 2 minus 3 repeated. This is repeated here. This is repeated. And this is 3, 2 minus 4, 3, 2. Like that. So now adjoint of A we can write here in this pattern, taking row wise, writing column wise in the adjoint of A. So 2 into minus 2 is minus 4 and plus 4. And this is minus 4 into 1, minus 4, writing column wise, minus 4, and minus 2 into 3, minus 2 into 3, minus 6, so minus of minus, this will become plus 6. And 3 into 1, 3, minus 1 into 2, 2. Then after that, taking this 1 into 5, 5, minus 3 into minus 2 plus 6, 5 minus 6. So now minus 2 into 2, minus 4, and 5 into 1, minus 5. Then 1 into minus 3, and 2 into 1 is minus 2. Then minus 3 into 4, 12, minus 5 into 2, 10. Then 5 into 3, 15, minus 4 into 2, 18. 15 minus. So minus 4 into 2, this will become minus of minus, it will be plus 8. 2 into 2, 4, minus 3 into 3, minus 9, that is plus 9. So we have minus 4 plus 4, 0, minus 1, this is 2, and this is 2, minus 9, 15 plus 8, 23, 1, minus 5, 13. This is the adjoint of A. So then we have find out A inverse. Find A inverse ಅಂತ ಕೇಳಿರೋದ್ರಿಂದ A inverse is equal to 1 by determinant of A, 1 by minus 1 into 0 minus 1 to 2 minus 9 23 1 minus 5 13. This is A inverse. Using this A inverse, you have to solve the system of linear equation. So the solution is solution of the system of equation is x is equal to A inverse into B. So here is 1 by minus 1 is minus 1, therefore multiplying minus 1 into each element, this is 0, 1 minus 2, 9 minus 23, minus 1 plus 5 minus 13. In this case, we have multiplied all the elements by minus 1 because this is 1 by minus 1 is minus 1 and multiplying into the matrix. So we have x is equal to A inverse into B. This is A inverse is finally we have 0, 1 minus 2, 9 minus 23, minus 1 5 minus 13 into matrix B is 11 minus 5 minus 3. Multiplying these two matrices, that is 0, 0 into 11 is 0, 1 into minus 5 is minus 5, minus 5, minus 2 into minus 3 plus 6. Minus 2 into 11, minus 22, minus 9 into minus 5, minus 45, plus minus 23 into minus 3 is plus 69. Then this is minus 1 into 9, 11 is minus 11, and 5 into minus 5 is minus 25, and minus 13 minus 9 plus 39. So that is equal to minus 5 plus 6 is 1, 2, because minus 22 minus 45 plus 69 is 2, and minus 11 minus 25 plus 39 is 3. So we have this is x, y, z. Equating the corresponding elements, we have x is equal to 1, y is equal to 2, z is equal to 3. So this is the solution of the system of linear equations. So in all these cases, we have solved all the types of the problems, and please go through the other problems given in the textbook, especially those equations having consistent solution, that is with unique solution, and system of equations they must be consistent with unique solution. Please go through that, and this is important for 5 marks in the examination. You can use the short tricks, but before using the short trick, you must be able to work out correctly without committing the mistakes. Very important. You can also do the first method, where we have find out the adjoint of A using the cofactors of each element, and finding the cofactors of each element separately. Okay. So that completes the whole chapter determinant. So we will discuss the concept, especially for this year, especially what are the deleted portions and everything other things in the next coming video. So up to that, thank you.